This is going to be a discussion and a demonstration for experiment 5, conductivity, for chemistry 141. In solutions, especially aqueous solutions, you have the ability to conduct electricity if you have freely moving ions. So I have 3 examples here, and I know your instructor is going to lecture on this, but I want to go through it briefly. Strong acids, strong bases, and completely soluble salts are going to completely dissociate in water and conduct electricity. And so we have the bond type for HBr, as my example, is polar covalent, but it's ionic in character. So it fully is ionized. It's going to have very good conductivity because everything's ions, so there's many, many ions. The major species are the hydrogen ion and the bromide ion, and this technically is even better being called hydronium, but whatever, you can call it hydrogen ion. The main thing here is there are no minor species. If I have something that's a good conductor, it will only have major species, which are those ions. And what am I going to see? I should see all the bulbs light up very brightly. Coming back to a weak acid, hydrofluoric acid, it's weak. It is still polar covalent, but it's not very ionized. It's only partially ionized because if you recall the definition of a weak acid is partially ionized and strong acid is fully ionized. That is the difference between a strong and a weak. So we expect poor conductivity. The reason being there are few ions. The major species is the whole molecule, HF, and the minor is the hydrogen ion and the fluoride ion, and I would see the bulbs light up dimly. Only poor conductors will have minor species. Everything else only has majors. And our last example is, even though potassium chloride is ionic, if it's in the solid form, there's no freely moving ions, so it's non-ionized. So there are no, we'll see no bulbs light up. There are no freely moving ions. The major species is the whole formula of KCl, formula unit, potassium chloride. No minors, no bulbs.